Hi everyone, welcome to our final class before spring break. All right, so for our final class, we're going to be taking a look at quadrilaterals and questions that involve quadrilaterals that you might see on the SATs. Now for today's class, what we're going to be focusing on, we've focused on properties of quadrilaterals. We did that before working from home. What I wanted to do is actually show you guys some new material involving area of quadrilaterals. So that's really what we're going to be focusing on today. So bear with me if you find this a little challenging. This is the first day that we're doing something that is slightly new. Some of this you guys have seen in middle school, or you might have seen on standardized tests, maybe when you took PARCC last year or some other time. Okay, so first section, we're going to focus on parallelograms. So remember some properties of parallelograms that we talked about. Sorry, just wanted to focus so you guys can see this. Okay, so some properties that we talked about is that the opposite sides of a parallelogram are congruent, the opposite angles are congruent, the consecutive angles, so angles next to each other, are supplementary, and the diagonals bisect each other. Okay, so for our example here, we're told that in PQRS, so our parallelogram PQRS, we're told that PT is x plus 2y, ST is 8x minus y, so ST is 8x minus y. PR, so the entire diagonal here is 32. TQ, I'm going to grab another color, so there's a lot going on here. So TQ is 26. And then in terms of the angles, angle 1 is 6A. Angle 2 is 10A. And then angle 3 is A squared minus 7. And angle PRS, so PRS is 4A. All right, so we have a lot going on here. So we need to figure out what the values of x, y, and angle PQR is. All right, so let's start with x and y. That's dealing with the diagonals. So we know that the diagonals of a parallelogram bisect each other. So that means that 8x minus y is going to be equal to 26. And what that tells us is because we have two variables, we're going to be using a system of equations. Now we also know that PT is x plus 2y. We also know that PT and TR are going to be congruent, so we can either multiply x plus 2y by 2 and set it equal to 32, or we could divide 32 by 2 and figure out that PT is going to be 16. So we would have x plus 2y is equal to 16. Now what we need to do is figure out how we're going to solve this system of equations. I think it's set up nicely for elimination, so I'm going to multiply this first equation by 2, and that's going to allow me to eliminate y. So I've got 16x minus 2y is equal to 52. Now in order to solve for x, I'm going to add straight down. That's going to eliminate my y. So I've got 17x is equal to 68. If I divide by 17, I get that x is equal to 4. Now I can plug that back into either one of my original equations to figure out what y is. So I've got 4 plus 2y. And if you're wondering which equation I chose this second equation. No particular reason. Is equal to 16. Subtract 16 on both sides, so 2y is equal to 12. So we get that y is equal to 6. Now what we need to do is figure out our angle measures. So what I want to do first is figure out what the value of A is, and then we can figure out what the measure of angle PQR is. Okay, so PQR, again, is going to be the combination of angles 1 and 2. In order to figure out what angle 1 and angle 2 are, we're going to have to set up some equation to solve for A. So what I notice is I have angles 1 and 3. those are alternate interior angles. So I have a squared minus 7 is equal to 6a. That's going to allow me to solve for a by setting this equal to 0 and then factoring. So I need two numbers that multiply to negative 7 and add to negative 6. So we have a minus 7, a plus 1 is equal to 0. So we get that a is equal to negative 1 and positive 7. Now the issue with negative 1 is if we plug in negative 1, 6 times negative 1 will give us a negative angle measure. So we know that a has to be 7. So now what we're going to do is plug that in for angles 1 and 2. So angle 1, if we plug in 7, 6 times 7 is 42 degrees. Angle 2 is 10a, so 7 times 10 is 70 degrees. So that means the measure of angle PQR is 42 plus 70, or 112 degrees. Okay, perfect. Hopefully that shook the rust off a little bit on the properties of parallelograms, and we can get started talking about some other parallelograms. All right, so for section 2 here, we're going to focus on some other parallelograms that we've talked about so far. So our special parallelograms and trapezoids. So that includes our rectangle, rhombus, square, and trapezoid. So for a rectangle, we know that there's 4 right angles, and because it's a parallelogram, all the properties of parallelograms are going to be true. For a rhombus, it's a parallelogram that all the sides are congruent. In a square, it's a combination of a rectangle and a rhombus, so all the sides are congruent, all the angles are congruent or right angles. And then for a trapezoid, that's a quadrilateral that has only one pair of parallel sides, meaning that the consecutive sides that share a leg are going to be supplementary. Then we also talked about isosceles trapezoids. Those are trapezoids that the legs are congruent. Okay, so here we have some theorems about trapezoids. So in a trapezoid, the midsegment of a trapezoid is going to be half the sum of the two bases. So our midsegment MN is going to be half of the sum of base 1 and base 2. All right, so let's take a look at what some SAT questions might look like with that. For this section, I'm actually going to give you guys 2 examples because we're going to be talking about area, and area is something new that we haven't really talked about much. Okay, so our theorems here talk about the area formulas for each of our figures. So for a parallelogram, it's the same as a rectangle, so the area is going to be the base times the height. A theorem for the area of a rhombus is 1/2 the product of the diagonals. But because we know a rhombus is also a parallelogram, if you're not given the diagonals, you're able to just use the parallelogram formula. So the area is equal to the base times the height. For a rectangle, that's the same as a parallelogram. For a square, same as a parallelogram as well. But since we know that all the sides are congruent, you can simplify that and call the area one of the sides squared. And then area of a trapezoid is 1/2 the height times the sum of our bases. All right, so let's take a look at a couple examples. So for the first one, we're trying to find the area of a rectangle. I know it's a rectangle because I see all of these right angles. And then I also notice that I have a 30-degree angle here, so I know I'm going to be using special right triangles to figure out the base and the height. So since we're given the hypotenuse, I want to find my short leg first. So that's going to be h, or my height. To do that, I'm going to divide 16 by 2. That's going to give me 8. Then to find my long leg, I'm going to multiply 8 by root 3. So that means my base is 8 root 3. So now to find our area, that's going to be equal to, remember we're dealing with a rectangle, so it's the base times the height. So our base is 8 root 3. Our height is 8. So we can say that our area is going to be 64 root 3 units squared. Or another way to write that, since we're finding area, it's a real world situation, you can use a decimal. If I ask for simplest radical form, you'll leave it as 64 root 3. If this were on the SATs, most likely it would be a multiple choice question, and the answer they would show is probably 64 root 3. But if they happen to give you a decimal, plug that into a calculator, and you'll have 110.85. All right, let's take a look at the second example for this section. And again, the reason that I was giving you guys two examples for this section is because we're taking a look at area, and area is something new that you guys haven't really seen much or haven't been exposed to. So for this one, we're given a trapezoid. We're given our two bases. We need to figure out what the height is. The reason I know that is because in the area of a trapezoid formula, it's 1/2 the height times the sum of the bases. So we're given both bases. We just need the height to be able to find the area. So what I notice here is on the left, I have a 45, 45, 90 triangle. I don't know why this keeps going out of focus. So I notice we have a 45, 45, 90 triangle. We know that the hypotenuse is 6√2. So to figure out what the two legs are, we're going to divide that by √2. That's going to give us a height of 6. It's also going to tell us that this part of the base is also 6. And then we have all the information we need to figure out what the area is. So I'm going to plug that into the formula. So the area is equal to 1/2 the height times the sum of my bases, so 8 plus 12. Now I'm going to simplify this, so 1/2 of 6, 8 plus 12 is 20. 6 times 20 is 120, so half of 120 is going to be 60 units squared. All right, let's move on to our final section. So our final section is dealing with polygons or regular polygons. So remember, a regular polygon is a polygon whose sides and angles are all congruent. Here we have some terminology. So the center, just like with a circle, the center is the center, so it's equidistant from all the sides and from all the angles. The radius works just like the radius of a circle. So PQ would be our radius, or I'm sorry, PO, because that's the distance from the vertex to the center. A central angle is an angle formed with the center, so like angle POQ would be a central angle. Interior angles would be like angles SRB. And then the apothem is the perpendicular distance to any of the sides of a polygon or a regular polygon. So side OA would be known as your apothem. Now, as far as these terms go, you're not going to be required to know these terms. I'm going to show you in terms of triangles and using right triangle trig to find the area. So you won't really need to memorize any of this terminology. Okay, so now over here we have some other formulas. So we have the sum of our interior angles formula, which we talked about a few days ago. We have the measure of each individual interior angle. We know that the sum of the exterior angles is 360. And then the formula to find the area of any regular polygon is 1/2 the apothem times the perimeter. Now again, you're not going to be forced to memorize that formula. I'm going to show you in terms of area of a triangle, so that way you're able to find the area of any regular polygon without needing that formula. So for our example here, it says a regular hexagon with length of a side of 4 is shown at right. So we're shown that all of these sides have length 4. We want to find the area of this hexagon. Okay, so first off, if we think about a hexagon, we can figure out what each of the interior angles are. Now, what I notice is these are both the radii. So that's going to tell me that these angles are going to be congruent. And what I'm going to focus on is finding the area of this triangle right here. Now, since we know that this is an isosceles triangle, QS is then going to be the altitude, which divides the opposite side. So we're going to divide it equally. So 4 divided by 2 is 2. Meaning that PS and SR are both 2. Now we need to figure out what the altitude is of triangle PQR in order to find the area. To do that, we need to figure out what this angle is. What we notice is this angle here is going to be double this angle. So to find angle QPS, what we need to do is find the measure of each individual interior angle of a regular hexagon. So that's going to be this formula right here. So N is going to be 6. We're going to use the formula N minus 2 times 180 over N. So 6 minus 2 times 180 over N, so over 6. That's going to give us 4 times 180 over 6. 4 times 180 is 720 over 6. 720 divided by 6 is 120. So that tells me that this angle in red right here is 120 degrees, meaning that angle QPS is going to be 60 degrees. So what I'm going to do is redraw triangle QPS, just to enlarge it a little bit to make it a little bit easier. I know this angle is 60 degrees. I know this side's 2. Now, we need to figure out what the altitude is. What you might notice is this is a 30, 60, 90 triangle. So it's up to you on how you want to find the height. You could either use special right triangles or use right triangle trig. Either way, you'll get that the height is 2 root 3. Then what we want to do is figure out what the area of this triangle is. So the area of this triangle, this right triangle, is 1/2 the base, which is 2, times the height, which is 2 root 3. That's going to give us 1/2 of 4 root 3, or 2 root 3. Now what we want to do is consider how many of those triangles will be formed in our hexagon. So what I notice is this one chunk PQR. There's 2 of those right triangles, and that'll be true for each of the sides. If I draw in my radii, I'm going to have 6 triangles because there's 6 sides. But remember, I'm focusing on the right triangles. So we're going to be doubling the sides. So that means there's going to be 12 of those right triangles. So to figure out the area of the hexagon, that's going to be 12 times the area of each of the right triangles, which will give us an area of 24 root 3 units squared. Again, if this were an SAT question, and it would most likely be multiple choice, so your answer most likely would be 24 root 3. But again, if it's a fill in your own response or a student produced response, you could use a decimal. So 24 root 3, we'll plug that into a calculator. We wind up getting 41.57. So approximately 41.57 units squared. Okay, so that would be your answer. All right, so that is our last lesson before spring break. Enjoy your spring break, everyone. I'll keep you informed on what's happening after spring break as I have more information. Please reach out if you have any questions. Enjoy the week off.